Okay, today I'm going to be going through the GCD program, which is the greatest common divisor. And so for those of you who don't know what the greatest common divisor is, basically it's the greatest divisor that divides two different values, just like said in the name. So if you have 12 and 8, their greatest common divisor is what divides 12, the largest number that divides 12, but also divides 8 equally with no decimals at the same time, which in this case will be 4. And say you had 150, their greatest common divisor obviously will be 50, because that's the biggest number that divides 50 and also divides 100. Same goes if you would have a number and a zero, then their greatest common divisor is going to be the number, and the other way around, which we're going to be doing in the video, in the recursion step that I will show you. So we're going to start by calling the function, and we're going to call the variables that we have used in the function in our int main. I'm gonna do this recursively um, first, and then I'm gonna show you how to do it with loops after. I have done the scan, and I will print out the function. I would have been able to call the function here and then print out the variables, but I'm gonna do it this way because it's easier. And now the tricky part is gonna be that we're gonna call the function, and we're gonna have to define it and what it does. So as I told you, that if one number is 0, then the result is always going to be the other number. So to put this into code, we can say that if x is equals to 0, then return y. And then else if y is equals to 0, then return x. Okay. Now we want to say what happens if x is larger than y. Then we said that this is recursion, so we're obviously going to call the function again. But what are we going to call it on? Obviously, if we have 12 and 8, to calculate the common divisor of them, we can do 12 modded by 8, which returns 4. But say you had 160, then you will be able to do 100 modded by 60, which returns 40. But this is not only it. More can be done to this, because if you mod 60 by 40, you still get 20. So the greatest common divisor of 160 is not 40, it's 20, actually. So to put this into the code in recursion, we can say that GCD y comma x modded by y. This means that it will mod x by y, and if possible, when it's going to return y, and then if x is larger than y, which still applies to the same condition, which in that case will be 60 and 40, then it will mod it again. We will just keep modding it until it's not applied anymore. And of course, in our else, it's just the same but the other way around. So if y is bigger than x, then return GCD x y modded by x. I saw I forgot some commas. Did I forget any more commas? Does it look like it? X, y, y, x. Obviously you don't need a condition here. I just did it to clarify, but that's the operation. And let's try and run this. 150, 50, 160, 20, 12 and 8, 4. Seems to be working correct. I made a little program to make it easier for those of you who didn't understand, just like always. I'm gonna go through it again. So first of all, we define a function which contains two variables. Then the two variables themselves. We scan the variables and print them out with the function. Then we call the function again, and we say that if one of the variables is equals to 0, then return the other one. And we say this just the other way around over here. Now, if one of the variables is bigger than the other, then we call the function recursively uh, on itself until the condition is not applied anymore. And if x is larger than y, that will be applied, and if y is larger than x, this will be applied. But this is else, so you don't really have to mention the condition. The program knows by itself. Now, this is how to do it recursively, and I'm also going to show you how to do it with a normal loop, which is faster because it doesn't have to calculate as much. Okay, I have just written some of the previous code because this is just identical to the first one. The only difference is going to be in the definition of the function, where we're going to be using a while loop instead of the recursion. But to do this, we have to declare a help variable called temp, and then we're gonna say this in the beginning, that if y is greater than x, then we will perform return GCD. No return actually, just GCD on y on and x. And you'll see what we'll do in this in a moment, because actually just because the operation will be performed on x modded by y. And if that's not possible, it will flip them around. And now we can just do the same steps that we did in the recursion. So if x is equals to 0, then return y. And the same way, but the other way around. So if y is equals to 0, then return x. Okay, now comes to the while loop. The while loop is gonna contain of while x modded by y is not equals to 0, then the loop will be going. And the reason we're doing this is because x modded by y, once that's equal to 0, then we have found our divisor. Until then, that's no divisor, which is why we're gonna keep looking. And the first thing we do in the loop is we store the value of x in the temporary variable. So now temp holds the value of x, while the value of x can be used for something else, which is why we're going to store the value of x in the value of y. So now x is y and temp is x. Now we can do y equals to temp, which is x modded by y, which is actually no, temp which is x and modded by y. So what this does is that temp holds x, x holds y. Okay? And then we're gonna and the y is gonna hold the value of temp modded by y. This is why we're gonna return y. And just to show you that this works, 150, 12 and 8. So this is the same. And I'm gonna go over this one more time. The beginning is pretty common. You can pause it if you want. It's just the same as we went through in the beginning. Um, Here, where we call the function again, we have a temp variable to store the values, because if we don't, they will be, let's just say they will be forgotten. The C won't know that we have stored, like we can't just say that equals to that. We have to store x in something before we store y in something else. And then this step is just says that if y is greater than x and not x is greater than y, instead of this operation performed on x, it will be performed on y. So just the other way around. If x is equals to 0, then return the other one, and if y is equals to 0, return the other one as well. The loop will keep going while x modded by y is not equals to 0, while that condition is not met. So once it's equals to 0, the loop is done. While it's not equals to 0, then we know that there is still more to do. X is stored in temp, y is stored in x. And then y can have a new value, which is temp modded by y. And we're gonna return y. And if it's the other way around, it will return. This is gonna be flipped, of course. So this is why this works for both cases. This is a little bit more confusing than the recursion, but I hope this made sense. And if you have any questions, feel free to ask, comment down below.